Today we will discuss another experiment of aggregate, which is the determination of the specific gravity and absorption test of coarse aggregate. Specific gravity. Specific gravity of aggregate is the ratio of the weight of given volume of aggregate to the weight of an equal volume of water. It is a measure of density of the aggregate material. Here is the title of the experiment: an experiment to determine different specific gravities and water absorption of given coarse aggregate. Here we have the apparatus, which includes a balance and a bucket, which is often called density bucket, an oven, a cloth to dry the aggregates, and the stand which carries this density bucket. Here we have the cloth which is used to dry the aggregate for finding the bulk specific gravity. Here we have saturated surface aggregate specific gravity. Here we have saturated specific gravity. These are different apparatus to determine different specific gravities of aggregate. Theoretical background. Specific gravity is the ratio of density, which is mass of unit volume of substance to the density of given reference material. Specific gravity usually means relative density RD, which is known as RD relative density with respect to water. Specific gravity is important in construction and engineering because it affects the weight and volume of concrete or asphalt mixtures. It also influences the amount of cement or asphalt required. It impacts the strength and durability of the final product and helps determine the absorption and moisture content of the aggregate. Specific gravity can be classified in three different types. Number one, we have apparent specific gravity, then we have bulk specific gravity, then we have saturated surface dry specific gravity. Bulk specific gravity is the dry mass and its volume. Dry mass is md and volume vb, whereas the apparent specific gravity is the dry mass md and volume vn. Whereas saturated surface dry specific gravity, we have the ssg, which is saturated surface dry mass and volume vb. Moving further, we will after some slides we will discuss what is this vb and what is this vn and what is the volume in saturated surface dry gravity. Now we will discuss three types of specific gravity that we have. Number one, we have the apparent specific gravity. The volume measurement only includes the volume of the stone aggregate, called net volume. In previous slide we have discussed here the apparent specific gravity, which have the volume vn. It is the net volume, which is the volume of the stone aggregate particles only. It doesn't include the volume of any water permeable voids. The mass of measurement only include the dried stone aggregate particles, which is md. Here we can see the md. And apparent specific gravity is formally defined as the ratio of the mass of unit volume of the impermeable portion. Here is the most important word, impermeable portion, which doesn't permit any water to enter through it, of stone aggregate. Doesn't include the permeable pores, which is explained earlier, which I have explained earlier, to the mass of an equal volume of gas-free distilled water at the stated temperature, which is 23 degree. Now we have the second type of the specific gravity, which is the bulk specific gravity. The volume measurement includes the overall volume of the stone aggregate. Here is the key word, the overall volume of the stone aggregate particle as well as the volume of water permeable voids called bulk volume VB. Here we have VB. Now you will have a clear explanation what is this VB. The mass measurement only includes the dried stone aggregate MD, which is same as earlier. The bulk specific gravity is formally defined as the ratio of the mass of unit volume of stone aggregates, including the water permeable voids at a stated temperature, to the mass of an equal volume of gas free distilled water at the stated temperature of 23 degrees centigrade. Coming towards the third type of specific gravity, which is saturated surface dry specific gravity, GSSD. The volume measurement includes the overall volume of the stone aggregate particles as well as the volume of the water permeable voids called bulk volume. The mass measurement includes the stone aggregate particle as well as the water within the water permeable voids, MSSD. It is formally defined as the ratio of the mass of a unit volume of the stone aggregate, including the weight of water within the void filled, to extent achieved by submerging in water for approximately 15 hours, to the mass of an equal volume of gas free distilled water at the stated temperature, which is 23 degrees centigrade. Now we have the water absorption. Aggregate water absorption is the increase in mass due to water in the pores of the material. It is the increase in mass due to water in the pores of the material. It is expressed as percent difference between MSSD and MD with MD. Now we have a new term, which is the blended aggregates. Blended aggregates refers to a mixture of two or more different aggregates combined in specific proportions to achieve desired properties and performance in construction materials such as concrete, asphalt or mortar. We have some benefits of blended aggregates. It improves the gradation. It can enhance the durability. It increases the strength. Economic benefits, we have usually locally available aggregates, reducing the amount of expensive aggregates can lower cost, and we have environmental benefits as well. A different method is used to determine G for fine aggregates and fines. No method exists to find G of blended. G means specific gravity of blended aggregates, which may consist of separate fractions of coarse aggregate, fine aggregate, mineral filler, etc. GSP of blended aggregate is mathematically determined using the formula, where here is our formula: P1 plus P2 plus dot, which is ongoing, P2, P3 and infinity, and in denominator we have P1 divided by G1, where P1, P2, P3 ongoing to the Pn are individual percent masses of different sized aggregate, whereas the G1, G2 and G3 are the respective bulk specific gravity of those aggregate. Coming towards the scope of the test, this test measures coarse aggregate masses under three different samples conditions, that is oven dry, no water in sample. Then we have saturated surface dry, SSG, water fills the aggregate pores, and then we have submerged in water, underwater. We have three conditions: number one, oven dry, then we have water fills the aggregate pore, SSG, saturated surface dry, where we use the towel to dry the surface of the aggregate, and then we have the submerged in water, where we use the density bucket which submerge in water, and then we calculate the mass. Aggregate specific gravity is needed to determine weight to volume relationships and to and to calculate various volume related quantities in Marshall mix design. The specific gravity test is crucial for some reasons, which are the density determination, moisture content determination, then we have void content, then we can determine the absorption, then quality control, mix design, strength and durability, and pavement design. Absorption can be used as an indicator of aggregate durability as well as the volume of asphalt binder it is likely to absorb. Water absorption, an indicator of asphalt absorption if more than 5% not used in high mix asphalt and non-durable aggregate. Material change, we have a change in aggregate mineral or physical properties can result in change in specific gravity. For instance, during quarry operation means to extract aggregate. Specific gravity of aggregate is monitored. An abnormal change indicates the quarrying has moved into a new rock formation. Coming towards the most important part of our test, which is the procedure. Point number 1 is that place sample in container, cover with water at a temperature of 15 to 25 degrees centigrade and soak for minimum period of 15 hours. Then we have to transfer the sample to the wire basket and rinse clean with fresh water. Point number 3 is that suspend the wire basket from the balance, immersing the basket and sample completely in water and determine mass submerged, say M sub, which we have discussed earlier that it is a condition of determining the specific gravity. Point number 4 is that transfer the sample into a large absorbent cloth which is surface dry condition and remove all visible films of water. Surface water can be removed by rolling the sample gently with towel. Avoid loss of absorbed water by drying the sample to surface dry condition as rapidly as possible. Determine mass saturated surface dry, say MSSG, without loss of time. Point number 5 is that transfer the sample to a suitable container and then dry to constant mass at 110 plus minus 5 degree, which has we have an error. We can have error in the temperature measurement. We can deal with plus minus 5 degrees centigrade. Cool to room temperature and then determine mass dry, say MD. Now we have to discuss that which surface or we can say the specific gravity is the largest and why. The largest we have the apparent specific gravity, then we have saturated surface dry specific gravity which is intermediate, and then we have the bulk specific gravity which is the smallest. Apparent specific gravity measures the volume of aggregate particles including the internal voids, so it's the largest, whereas the SSD, which is the saturated surface dry specific gravity, measures the volume of aggregate with saturated surfaces but no excess water, so it's intermediate, it's in the middle. And then we have the smallest, which is the bulk specific gravity. The volume of aggregate including the volume of aggregate including the interparticle voids, so it's the smallest. We have typical ranges for these specific gravity values, that is apparent specific gravity, which is 2.5 to 3.0. Then we have saturated surface dry specific gravity, which is 2.3 to 2.8. Then we have bulk specific gravity 2.0 to 2.6. Observations and calculations. Here we have the mass which we have determined either in 3 different conditions, which is saturated, surface dry, or submerged, and bulk. Then we have to multiply with 100 and divide the md minus m sub, which is md the mass of dry aggregate minus m sub, which is submerged in water, which is the formula of apparent specific gravity. Then we have the bulk specific gravity, where we have the dry mass multiplied by 100 and divided by mssd. mssd surface saturated dry mass minus m sub, which is saturated submerged mass. It gives the bulk specific gravity. Then we have the saturated surface dry specific gravity, which can be calculated by mssd, which is saturated surface dry mass multiplied by 100 divided by saturated surface dry mass minus m submerged mass, and it gives the saturated surface dry specific gravity. Then we can have the calculation of water absorption. Water absorption can be calculated by mssg minus md multiplied by 100 divided by md, which will be in percentage. Discuss your results in the light of the normal values of specific gravity of coarse aggregate, which we have discussed earlier, that the range of different typical ranges for different specific gravity values. Thanks for watching.